Hello, this is my submission for Lab 8, Probability and Belief Networks. Preliminary question A asks to explain what it means when two variables are independent. And two variables are independent when the probability of one variable is the same as probability of that variable given the other. So you can see here, P of x given B is the same as P of x. That makes x and B independent. Two variables are conditionally independent when it's better explained with this example. Here you could see probability of A given x and B is the same as probability of A given B, which means that once we know B, finding x gives us no extra information regarding the relationship between A and B. In this case, both A and B are conditionally independent from x. And the independence assumption in belief networks is that any variable is conditionally independent from other non-descendant variables that are not its parents. So once we know the values of the parents of a certain variable, we do not gain any extra information from finding other variables, for example, the parents of the variable's parents. Then we can go into AI space and open this problem, the sample fire alarm problem. And we can go to solve, and question D asks what is the probability of the smoke variable being true when we do not know anything. So just remove all these observations and then we can query the smoke variable. You can see that the probability of it being true is just under 2%. Question E asks, observe that the fire is true. Now, what is the probability of smoke being true? So we observe that the fire is true, and then we can query the smoke. And now you can see that the probability is 90%. So the probability has greatly increased now that we know that fire is true. Question F, observe that the fire and alarm are both true. What is the probability of smoke? So, oops. So now we can make an observation, say that alarm is true. Query the smoke. You can see that the probability of smoke is still 90%. It remains unchanged. The answer to both E and F are the same because smoke is conditionally independent from alarm due to the belief network assumption. And then part 3, we can go to the independence quiz and look at that. Actually, let's first remove all these observations, and then we can go to the independence quiz. So there we go. Go to the independence quiz, ask the applet, ask a question. Is leaving independent of fire given alarm? So is leaving independent of fire given alarm? And then get answer. The answer is true. Leaving is independent of fire given alarm because leaving and alarm are conditionally independent from fire. Just leaving is conditionally independent from fire. Next question, is leaving independent of report given alarm? Is leaving independent of report given alarm? The answer is not independent of report, as this is a descendant of leaving, so it is not a part of the independence assumption of belief networks. And that is it. Thank you.